Hey everyone, I'm Donna Wittig and I run the Delaware Valley nonprofit user group. So if you're in the Delaware Valley, we cover Delaware, kind of Chester County area mostly. We meet sometimes in Downingtown, Westchester, or Delaware. And I'm here to introduce the first speaker, which is Michael Smith. He's a senior member of the technical staff at Salesforce.org. He's a 7-time certified technical developer and architect, and he is part of the exciting team that does all the good things at bringing the nonprofit starter pack to the next level. And a couple fun facts about Mike is he wrote his first line of code on the TRS-80 color computer, which is also a Tandy Radio Shack. Yeah, I know what that is. That's dating me too. And he hopes someday to open a restaurant called Mike's Beer, Bikes, and Burgers. And of course, he would run it on the Salesforce platform. So without further ado, let's give a good warm round of applause to Mike.
Thank you, Donna. Good morning, everyone. Welcome to the Philly Force Conference, right? Again, echo what Alex said, there's the Philly Force Developers Group that meets regularly. But a huge thank you to Alex, Kirk, Gina, Donna, Carl, all the other speakers, sponsors, everyone who has helped grow this into our largest conference ever. So, as Donna said, my name is Michael Smith. I'm a developer on the nonprofit Success Pack. I know Judy was certainly cringing, right? We were the nonprofit starter pack for many years, but the product is matured at such a level that it is the nonprofit success pack. We're bringing success to our nonprofits. Today we're going to talk about some of the challenges that we overcame in building a new customizable roll-up solution for the product. Before I begin, just a quick note talking about considering future developments, blah, blah, blah. Customizable Rollups has not yet been released. It's due later in the month of May, and so technically it's a forward-looking statement is necessary. So many of you might ask, what is Salesforce.org and how is that different than Salesforce.com? It's actually a question I get frequently. We all know technology is most powerful equalizer of our time, right? Providing access to data, knowledge, and above all, to connections. So we aim to get our technology in the hands of nonprofits and education institutions so they can connect with others and do more good. Born out of Salesforce's 1-1-1 model, Salesforce.org has evolved into a self-sustaining social enterprise where the more missions our technology supports, the more we can invest in our community, creating an endless circle of good. Salesforce.org is focused on our customers to drive change, or ability to drive change. Our customers in the nonprofit, education, and philanthropic industries are using our technology to expand impact in critical social sectors. With creating a better world as our common thread, the 3 industries that Salesforce.org currently supports are nonprofit, education, which includes both higher education and K through 12, and finally, philanthropy. Today we're going to talk about Salesforce.org's most widely used product, the nonprofit Success Pack, and more specifically within that, donor statistics, also known as Rollups. Among addressing other business needs for our nonprofits, one of the areas that NPSP, which is the acronym for Nonprofit Success Pack, and one you'll hear me use pretty much throughout the rest of the talk, attempts to solve is around rollups. For example, rather than force our customers to run a report to see what the total donations are for a given contact or household, we've built in various rollup fields right on the contact and account objects that summarize this data, so it's one-stop shopping for them. And before we get into the fun behind the Nonprofit Success Pack and rollups, I feel like I need to just give a little quick primer on our data model. So first, accounts in the nonprofit startup. Boy, yeah, I've heard it too many times today. I can't remember the last time I used the word starter. First, accounts in NPSP are like any other account. However, because most nonprofits are effectively a B2C, accounts are primarily considered a household, like a household account. Contacts attached contacts attached to that are generally family members in the household. And of course, as you might expect, we can also have organization accounts as well. And then we use relationships and affiliations to link together those employees as contacts who might have driven those organizations to give gifts. Second, opportunities generally refer to donations either pledged or received. Through record types, NPSP is also capable of managing in-kind gifts, grants, major gifts, matching gifts, and other types. The product also supports a few additional custom objects related to donations that are a little bit relevant to our discussion today, so I'll just give a quick high level. There are soft credits. Soft credit is a credit for a donation that a contact or a donor did not actually make themselves, but they may have somehow influenced. It could be a family member. Maybe my spouse gave a donation, and so I will get soft credit for that. Payments are basically what they sound like, payments against a pledge. And allocations, a little bit more complex, but many nonprofits use general allocation or general accounting units, or GAUs, to track donations. Allocations are a way to allocate received donations into one or more GAUs. It's basic accounting. So now that you have a feel for the NPSP data model, let's talk a little about what rollups actually do in the product. At the simplest level, and this is a pretty simple model, donor rollups refer to statistics on the household accounts and contacts that sum, average, count, and tally other statistics about related donations for the household and for the contact. Obviously, the reality of rollups is much more complicated than what I'm showing up here, but it gives you a rough idea of what's going on. And you can see that on the far right, we've got soft credits coming in. On the left side of that are hard credits, meaning those are donations that they directly made. You might ask, well, why not just do this using standard rollup summary fields that the product has right out of the box? Well, there are a few good reasons for this. First, there's no support for rollups to the contact object from the opportunity using standard rollup summary fields. There's no support for date filters. There's no support for rolling up from a child object of the opportunity all the way back up to the parent account or contact. And finally, there's no support for rollup operations other than the basic set of sum, min, max, and average using standard rollup summary fields. And these are all very good reasons why we cannot use those. Our rollups go far beyond what the standard rollup summary fields are capable of supporting. So there's going to be a lot of acronyms in this discussion. I felt I should give you a little bit of a guidance in this. I'll leave this up here for a few seconds, but these are some basic acronyms that you'll see throughout the rest of the presentation that I thought might be a little bit helpful. I'll just leave that for a second. I'll drink. And move on. So if you're curious, here are the 41 package rollup fields that we include on the contact object alone. There's another 26 on the account and another 15 on the general accounting unit object. And then there's a handful more on recurring donation. You'll see these referred to again as we move forward, but I wanted to give you an idea of the scope that we're referring to when we talk about rollups. The initial implementation of donor rollups that we're replacing leveraged what's called aggregate SOCL. I know it's a technical presentation. I'm trying not to keep it too technical, but there are some base things we should talk about. So aggregate SOCL is this query we see on the right. That worked very well for the majority of our customers for a number of years. Right? NPSP has been around for quite a while. But it does suffer from various limitations of the platform, such as governor limits and a very limited set of possible operations and fields that can be rolled up from. So, as a result, we looked at this and felt, well, we need to come up with a better and more robust solution. And that brings us to our current initiative, what we call Customizable Rollups. By creating a new way of rolling up donor statistic data, we're attacking multiple business issues at once. First, reliable and consistent multi-currency conversion in the product during rollups. Support for fiscal years. Support for organization with millions of records or hundreds of thousands of related opportunities for a singular account or contact. cash accounting by supporting the roll-up of payments to the account and contact. New types of roll-ups, such as a list of years donated or the current streak, meaning the number of years in a row they've actually made donations. Custom roll-up filters against nearly any field on the object being rolled up from. And finally, allowing our customers to create their own roll-ups against the supported object types using our engine. Now, you might notice that the issues addressed by customizable roll-ups are very specific to the NPSP data model. The solution that we're building is really in no way intended to displace other third-party solutions like DLRS or Rollup Helper that can provide scheduled and on-demand roll-ups across many standard and custom objects. Instead, Customizable Rollups addresses the very specific needs of our nonprofits, and it handles roll-up operations across multiple layers of objects and using aggregation types, things like best year or a list of years donated, right? These are things that are not supported by other roll-up tools. Before I get too far into this, I just want to give credit to the entire team, right? This was a team job. This is Team Honeybees. This project would not have gotten off the ground without Team Honeybees, as well as release engineering and the wonderful community team of which Judy there is in charge of, and we could not have gotten anywhere without all of their support and guidance. All right, moving on. One of the big changes we made with customizable rollups was the move to something called custom metadata types, which everyone's probably heard of at this point. Now, NPSP does not package custom metadata type records with our installation. However, an org admin can enable the new customizable rollups tool in their organization, and that will use what's called the Apex Metadata API to deploy the rollup configuration as custom metadata type records, pulling the configuration from their current settings, which is located in where you might expect custom settings. And you've probably heard Salesforce talk about the migration from custom settings to custom metadata types, and this is a very good example of how we are doing that. Here's just a little bit more detail on the model that I've got shown here. Each rollup definition has a filter group associated with it. Each filter group is a collection of one or more filter rules attached to it. A filter rule is simply an inclusion condition, such as is 1 equals true, or record type equals donation. For example, a filter group with the name closed won donations might actually have two rules associated with it. One for is 1 equals true, and one for record type equals donation. Pretty simple. And here's a quick picture of the customizable rollups UI showing a filter group. Filter groups can be used by one or more rollups, and as a result, by default, there's only a handful of pre-included filter groups in our package, which means they're shared across many of the rollups, making it easy for our users to change those rules and apply it across multiple rollups. The customizable part, of course, comes in because they can go in and modify those however they want. They can make a new filter rule, new filter group, and they could say, well, I want this rollup to only use these conditions, and I want that rollup to only do it this way. Or I want this rollup to use custom fiscal years, and I want this rollup to use calendar years. So it's completely customizable. We've expanded well beyond what our current version of Rollup supports, and again, as well, beyond what most other Rollup tools would tackle. Now, moving the Rollup configuration to custom metadata types actually gives a few new capabilities for our customers. First, custom metadata type records can be deployed between organizations, such as from a sandbox to a production org, using a very simple change set. That wasn't possible before. You would have to do an import-export. Custom metadata type records offer far more customization than the simple custom settings that we used to provide in the package for rollups. And third, unlike custom settings, which are considered data, custom metadata type records are considered metadata. And as a result, they are copied to sandboxes automatically when you create or refresh them, even a Dev or Dev Pro sandboxes. And for those admins in the room, you know, if you create a Dev or Dev Pro sandbox from your production org, it gets no data in it at all. It's completely empty. Well, that would include custom settings. But custom metadata types are not data. So you create a Dev or Dev Pro sandbox from your production org, and this comes right along with it, which makes it much easier for an admin to create a sandbox and go in there and continue to work and not worry about losing that configuration. At a high level, Customizable Rollups takes three approaches to rolling up our donor statistics to the household account, the contact, and general accounting unit objects. First are queuable jobs. These are called by triggers to take on rollups that will fit within the governor limits, meaning they can be done pretty much on the fly without worrying about going over the 50,000 row limit that Salesforce enforces. Secondly, contacts at accounts that have less than a defined number of related opportunities, we use a standard Apex batch job. Batch job is just something that runs across many records at once. In our standard job, we are using the main query locator is on the parent account or the contact. So we first select our account and contacts, the group of those, and then the batch selects all the opportunities related to those accounts and contacts and rolls them up. And again, that needs to fit within governor limits. And finally, for contacts and accounts that have potentially more opportunities than can be queried in a standard batch job without hitting a platform governor limit, Customizable Rollups implements a new type of rollup job, the Skew batch job. Skew job starts with a query on the opportunity, the detail level, and is able to sort the data by that parent account or contact and roll that data up using that approach. In theory, this can roll up millions of attached opportunities to a single account or general accounting unit. In fact, I have rolled up millions using this methodology. All right, that's quite the chart up there, right? So I could spend hours talking about the architecture of the Rollups engine, and it certainly took me a long time to build this out. Suffice it to say, it does work well, but as with anything, as an architect, right, if time were no object, I'd go back and refactor some of the engine structure. So just to give you a quick high level on that, I designed this virtual class off an interface, which is represented at the top of the chart there, that could be instantiated dynamically based on these different types of rollups that we have. And of course, rollups are dynamic, coming from a custom metadata type record, so nothing's hard-coded. It was an ambitious design, and it does work, but in the end I found there were a lot of, well, in this condition you have to do it this way, and if this is the type of rollup, you have to do it that way. So a lot of ifs and branching logic, and in the end I ended up moving a lot of that logic into different methods and different service classes. But in a perfect world, I would have encapsulated all that logic right within those individual service classes to begin with that were based on the different rollup types. So for the developers, if you can't tell, the product teams at Salesforce.org really have a very fond relationship with this incredible book. And Andy, I don't know if he's here yet, but this is Andy Fawcett's book, and he'll be coming up later to talk. As the previous slide noted, there are two rollup mechanisms in use. Triggers through a queuable job, and then two different types of batch jobs. And then these are called through 4 different entry points. First, Apex triggers on an insert, update, delete, or undelete will call, on opportunity that is, will call a queuable, and that trigger dispatcher will call the correct type of job to roll up that data on the fly. Second, we've got scheduled batch jobs. There's a nightly job that runs every single night to cross all the rollups to handle things like end day. An end day rollup for us is rollups in the last 365 days. Which means for that to be accurate, it needs to be recalculated every night because 365 days changes relative to the day of the week it is. So those run every night. And those are intelligent enough to split up between our standard batch job and data skew based on the type of rollup that it's dealing with and the number of records. There are on-demand rollups as well. There's a recalculate rollups button on the account page layout, the contact page layout, and the general accounting unit page layout. Click that, and it'll immediately recalculate the rollups just for that one record very quickly and bring the user right back. And then finally, there is a button on the NPSP settings page that will let the admin run the rollups for the entire system, which basically reproduces what the scheduled job does. It just does it on the fly. So now that we've delved into the basics of the customizable rollups architecture, let's talk a little bit about the challenges that we face just building this out. So first, there are 3 main challenges we had to work with. The metadata API in Apex, the performance of the Rollups engine, and batch job data sequencing in Skew mode, which nearly turned me gray. So let's start with custom metadata types. The metadata API in Apex was released in spring 17. There are 2 primary areas of complication with the metadata API. And for those not familiar with metadata API, all this did was it gave Apex, the programming language within Salesforce, the ability to manipulate some parts of the metadata right from within that language framework, where previously that was not possible. Almost all of metadata, either querying or manipulation, had to take place outside of Apex using JavaScript and some other tools. So the metadata API in Apex does not support deleting custom metadata type records. So imagine you're in there doing your rollups work and you create a rollup and you go, I don't want to do this, I want to get rid of this one. It's a mistake, I want to delete it. Well, there is no delete in the metadata API. So we worked around this by creating a simple isDeleted flag field on our record, and we just simply set that field to true as an update instead of a delete, and then our queries exclude all records where isDeleted equals true. It's a workaround to a limitation of that API. Oop, sorry, I missed a click. Second, the more complicated issue is the deployment of custom metadata type records. It's an asynchronous process, meaning that you start it, and then it goes off and it runs on its own, and you return back to wherever you were doing, your user interface or whatever, and then when it's done, you have to kind of check on that. There's a process for that. Now, even though you can query custom metadata type records using what's called SOCL, or Salesforce Object Query Language, like you can any other custom object, you can't actually insert or update those records using what's called DML, which is what you would use to insert or update an account or a contact. Instead, you have to use this deployment process as part of the metadata API, and that is asynchronous. The issue is, if I'm on my UI, right, so here I am on my screen, I click Save. Normally, you're on a page, you click Save, right, the hourglass turns, and it comes back and says, yes, I saved, no, there was an error, whatever. It's all this one continued process. When you're dealing with an asynchronous deployment like that, you click Save, it goes off, and it returns back to the page, but that deployment is still running. It's running in the background somewhere. You have no control over that. So we needed to create processes to be able to keep an eye on that so the user doesn't think, oh, it's saved, when in actuality it didn't. And so that was something that we had to work on. All right, I'm going to try and keep this explanation short and not too technical, but here goes. When a user clicks Save, an Apex controller is called to handle structuring the custom metadata object from what's on the screen, and it calls the metadata API to start the deployment process. At the same time, when they click Save, a polling process starts on the Lightning user interface that is calling an Aura-enabled method in our Apex controller every few seconds. And you can see that represented by the flashing clock and method there on the far right side. On the Apex controller side, the deployment is queued in that asynchronous process, passing in a reference to what's called a callback class. And a callback class is just a thing that Salesforce is going to literally call when it's done. When the deployment does complete, that callback class is called, and the handle result method, which you can see down there on towards the bottom, is called with the result detail. Now, that result detail is a success or failure message, and it's written into a custom settings object. So what we're basically doing is saying, when the process completes, put the result somewhere that the page can find it. Because that's the whole deal, right? The page is still running, the user's still staring at their page, but it has no way of knowing when it's done on the other side. So the callback waits for it to complete. It writes the status into some place that the page can then query every few seconds to look, is the field updated? Is the field updated? Is the field updated? Oh, yes, the field's updated. I have a status. Yes, it worked. No, it didn't. Here's an error message. And finally, when it's done, it displays that in what's called a toast, a little pop-up on the screen, and the polling goes away. So this works, right? This is how we built it. This is a very common design pattern, and it does work. But it's actually not the most efficient method to handle asynchronous anymore. Longer term, the team would like to implement what's called platform events to handle asynchronous deployment notifications. There just simply wasn't enough time for us to complete this in our current priority items, but it is on our backlog. Just high level, right? In a platform event implementation, it's basically the same process. The asynchronous callback is started. It's just that at the end, rather than write the status to some field that the user interface is constantly querying back every few seconds, we can trigger what's called a platform event, which is a relatively new feature in Salesforce. The platform event can be listened to from the UI side. So there's no polling going on. The UI just simply listens. It's out there waiting for some kind of notification. We create the platform event when the deployment is completed. The user interface hears it, and it can go pop up that message to be a much more efficient flow. It's on our backlog. We hope to get to it, but it's not going to be in the first release of the product. The next and more complicated issue is around what's called the performance of the rollups. When we first started this work, the thought was rather straightforward. Now, I just want to note that this is only pseudocode that I'm going to show, meaning that it's not the actual real code, but it just gives you a rough idea of what we're doing. Anyway, we have a bunch of rollup definitions in a custom metadata type object to roll up for each target object. Right? We looked at that long list of 41. Whether target's an account, a contact, or a general accounting unit. The logic would be to first loop through all the parent contact records being rolled up to. Within that loop through all the opportunity detail records that are attached to that contact. And then finally, loop through all the rollup types that need to be rolled up for that contact using those opportunities. So I've got 3 nested loops there. At scale, that will definitely generate a CPU timeout error. As you can see, at a simple level, there's 26 package rollup types for what's called contact hard credit, which is what would be rolled up in a single operation like this. If a contact has 100 attached opportunities, which is not very many, and the batch job is doing 200 contacts in a single batch iteration, which is the normal default amount, that math becomes fairly simple when you're dealing with 26 rollups. Over 500,000 loops through that set that I showed you before. Yeah, exactly. Not good. So how do we solve for this issue? Well, essentially, the rollups engine starts by first looping through all the rollup types, that 26, and then tries to group those rollup definitions by a set of common attributes. The result is a much smaller set of rollup definition groups that can aggregate data from multiple rollups at once. For example, all the simple total amount, count of gifts, this year, last year average, max, min, etc., can all be completed as a single operation because they're all sharing the basic same set of values. I'm rolling up the amount field across all records. Pretty straightforward. The same thing is true for some of the other types. There are some that are a little bit more complicated, like first close date or last membership date have to be kind of split out a little bit differently because the engine is dynamic, nothing is hard-coded, and that type of single operation needs to be split out from others because we're rolling up, maybe in one case I'm rolling up this kind of field, and the other place I'm rolling up that kind of field. So those are handled a little bit differently. The end result is that the inner loop is much smaller. You can see that there. Top inner loop is much smaller, and our total batch iterations in this case, right, we went down from 520,000 to 160,000. So it's an extremely significant reduction in number of loops, which means that this is a lot faster. And I want to credit Nick Campbell gets the credit for coming up with this idea, and it was genius. The final and most complicated thing we had to overcome was around batch job data sequencing. And like I said, this one literally was driving me gray. Again, before I get too much into batch jobs, there's some terminology. I thought this might be helpful who those are not intimately familiar with Apex batch jobs. And again, I'll let you read that while I drink my coffee. Good coffee. Okay, moving on. All right, so first thing, everything we're going to talk about with this part is specific to skew mode batch rollups, right? We talked about skew mode before, and that's where we've got more or potentially a significant number of opportunities attached to a single account, contact, or general accounting unit. More than can be queried in a single SOCL query, or when using a single parent record, or when using a batch job where you're querying all the opportunities for 200 accounts at once. And Salesforce has a governor limit that says you can't query more than 50,000 rows in a single transaction, which includes a whole bunch of queries that occur within one bit of execution. So if you've got, 100,000 opportunities for a single account, well, you're obviously going to blow through that limit really fast. So a good example of that are organizations that use the general accounting unit allocation for every donation. If an org has 100,000 opportunities in total across their entire organization, right? That's not that many. That's a pretty small amount. And they are using a default, that would mean that there are 100,000 allocation records attached to a single general accounting unit record, because we're using that one GAU as a default for every opportunity. That means that for that GAU to roll up, it has to roll up 100,000 allocations to that single GAU. Well, 100,000 greater than 50,000. So that will break Salesforce's governor limits. And so we use this type of Skew mode rollup to handle that. So to allow rollups to still work in this type of data skew scenario, our Skew mode batch job queries the detail opportunity object or allocation object in the other example as the main query. So instead of starting with the GAU and then querying all the attached, we can query on the detail object. And in a batch job, the main object that you're querying can query up to 50 million rows, not 50,000 rows. So it's a huge difference. We query that and we sort it by the parent ID, account ID in this example. Now what I had expected to happen in a batch job that sorts data, right, you can see the big green box there, sorts data by account ID, is that the SOCL the data would be sorted correctly and delivered correctly to each child batch in that order. And you can see that, right? We're querying all the opportunities, sorting by account ID. I get a nice neat table, account A, opportunity 1, 2, 3, 4, 5, account B, blah, 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 all the way down the line. The batch job sends it in little batches of 4, and they're nice, neat in sequence. Unfortunately, that's not exactly what occurs here. Because the processing opportunities for a single account or contact or GAU might span more than one batch iteration, there's a stateful variable, which is one of those terms that was up on the page before. It just means it's sitting in memory, and it's trying to hold this data in memory through the life of the job. And if it's delivered in a nice, neat sequence, right, I only need to hold that information for a very short period of time. I only need to hold it for one account because I'm never rolling up more than one account at a time. And then that heap size would be very small. And that would have been wonderful, but not. So the first thing I want to tell you about this is actually documented behavior, right? So I ran into the problem, and then I looked it up in the documentation, which of course is the way you do everything, right? You try to put it together first, and then you read the instruction and go, oh, that's where that screw went. So I read this and I went, well, okay, the order of execution is not guaranteed. That's an understatement. In the little example that I gave, a Skew mode batch job with a batch size of 4 might get blocks of opportunities for account A as that first batch iteration. And the next would be account B, and then it jumps to account H. So get this little example here. This animation should show it. And you can see as the boxes move along, so the first batch, child batch iteration at the top is account A, and then it jumps to account B, then account H, and then D, C, and then at the very bottom, oh, look, there's the rest of the opportunities for account A at the very end. Now, in practice, I saw this, we were doing much larger batch jobs. Thousands of child batch iterations, querying millions of opportunities, and it would skip stuff for thousands of batch iterations. Hours would go by before stuff was picked up. So it is significantly out of sequence. And from a rolling up perspective, that makes life more complicated, right? If you're looking at a block there, right, let's say you've got the second block, which starts with account B and ends with account C, and that second block on the top right, you would think, okay, well, I have an account B. It's the very first opportunity is for account B. Were there other opportunities for account B in another batch that I just didn't get yet? I don't know. The last one is account C. Are there more opportunities for account C that are going to come in a later batch down the road that I still haven't gotten yet? I don't know. There's no way to know. The first and last are always the wild card because I don't know. It's not in sequence. When we were looking at the other one, I always knew it would be A, and then the account would change, and then I'd get all the opportunities for account B, 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 et cetera. We lose that sequence here. There's no way to know. It becomes somewhat unreliable. So in reality, this looks a little bit like this, and hopefully this makes it up clearly. So you can see how the rollup data is accumulated in the heap as the account ID changes for the first and last account ID in each iteration. So you can see the heap is the big blue block there in the center, and it keeps adding on. Every time I get a batch iteration, I'm now saving more data because I don't know. Is there more opportunities for this? I can't just write the stuff out to the account record and say I'm done rolling it out because I don't know whether there will be more or less. Till I get to the very end, and then at the very end, then I can write out whatever's left. But in the meantime, I've been sucking up heap space. Well, this will work for a small number of records, but in practice, it will break down with somewhere around 250 different roll-up summaries, where each of these blocks represents a roll-up summary, which is just an aggregation of all the different roll-ups for a given account. So it's all the sums, all the last dates, all the averages, all everything, so that as it's rolling up those opportunities, that's where it's accumulating that information. So I can only hold that for 250 accounts. Well, most nonprofits have more than 250 accounts. And so in a large enterprise, this will definitely break down. So after some brainstorming with Nick, some great overnight thought, probably a couple of beers along the way, we settled on what's called a Skew mode dispatcher. And the premise is fairly simple. The real issue is the maximum number of stateful summary record collections that can be kept in the storage heap. A lot of words, right? All we're saying is, how much can we save in memory while we're doing this entire batch job without blowing up? The resolution is to reduce the number of accounts, right? I said there's a maximum number you can get to before it blows up. So I'm using accounts here as the example, but reduce the number of parent records that the actual batch job processes at any one point in time so that we never hit that limit. So I might be working in, let's say, I don't know, a huge organization that's a nonprofit that has 30 million opportunities, and many of those opportunities are attached to accounts that might have a couple of 100,000 donations apiece, particularly organizations that might be doing matched gifts or things along those lines, with lots and lots and lots of donations. So in those cases, we need to be able to roll that data up. So it is very possible to have 1,000 accounts, each of those 1,000 accounts having 10,000 or more attached opportunities. And so rolling those up at scale in a nightly batch job would be complicated using that manner. But we break it down into little chunks now. Each small group of record IDs is sent to this Skew mode batch job, and it breaks it into little tiny chunks. I'll give you a different view of that. So when looked at as an entire process, you get something along these lines, and hopefully this slide makes a little bit more sense. The Skew mode dispatcher, here on the far left, that executes first. It selects all the accounts that require Skew mode, right? All the ones that have a lot of attached opportunities. But it does it in very small groups. In this case, it says, only give me 4 at a time, just 4 and no more. That small group of account IDs is passed into the actual rollups job, which is the big green block on the right. And then it does the rollup for just that set of accounts. So our heap size never gets exceeded. I'm dealing with a small number of records. When that job completes, it sends it back to the dispatcher job and says, oh, hey, here's the last account ID I worked on. And the dispatcher runs its job, and it says, all right, get me the next set of accounts that need to be processed this way. Again, in a small block, 4 here. Dispatcher sends that next group of accounts into the batch job again. It's the same batch job. I just made a copy of it a little lower to show the different accounts. And again, it runs and completes, staying well within the storage limits that Salesforce provides. And when it's done, it sends it back to the dispatcher again. And this time the dispatcher says, oh, there's no more accounts left. I have nothing left to do. And so it shuts itself down. So this execution pattern, which also is a form of what's called PK chunking, or primary key chunking, has been successfully tested against millions of opportunities with data scenarios such as like 60,000 opportunities attached to a single account, or even 60,000 attached to more than one contact, and over 2.4 million opportunities attached to a single general accounting unit. And actually, believe it or not, performance is very, very acceptable with this. I can roll up, a few million accounts or few million account allocations to a general accounting unit record in just a couple of hours, which is very acceptable. So, in summary, these are three of the main challenges that we had to overcome in building customizable rollups. Obviously, there were others along the way, but these in particular required some fairly complex design of the architecture. Overall, there were some high-level assumptions that we had about rollups going way back, because as I said, rollups has been around for quite a while in the product. We had to throw those out to come up with a more robust and scalable solution. We tried very hard to verify every step along this process, even getting into excruciating details, such as analyzing loop performance by following and reevaluating the performance tests that Paul Battison had completed in his YouTube video series, which, if you're writing Apex and you haven't seen his performance videos, I highly recommend looking those up. That about does it for the main part of the presentation. Since customizable rollups itself is a fairly large set of new functionality, there are some new features I thought I really should just kind of mention to close out our discussion today. First, it is a full Lightning user interface to allow our admins to customize rollups. For those Lightning developers in the audience, this brought about its own whole set of challenges, but that is a completely different presentation for a different point in time. Customers can now define batch job sizes for each individual batch job in the product. This was something that didn't exist before. Previously, they got one batch size number, and every batch job shared the same thing, which works unless you've got a lot of data scenarios that require some unique batch sizes, and then it became a challenge to figure out what's the optimal batch size to work across every different job that the product runs. We'll support the platform cache in the product when using advanced multi-currency, which is dated exchange rates, to improve performance. So the organization has 1,000 dated exchange rates in their organization, and we're trying to roll up data. Well, we can store that information in the platform cache and leverage that during our rollup, so the product isn't having to query to get the right exchange rate to use for conversion as it moves through all the records. We can roll up from nearly any field on the opportunity object, where previously it was extremely limited. Our Skew mode determination, which is what determines what method to use, is based on the number of related opportunities. So every household account and every contact actually has a field on it for the total number of donations. Well, we can use that field to know, does this need to be rolled up using a regular batch job, which can be done pretty quickly and simply, or does it need to use this new Skew mode methodology? We now support rolling up soft credits to the household account, which was not something that we could previously do. Mike likes that. The recurring donation rollups will now use the rollup engine as well to better handle data skew, which is a problem with some of our larger organizations, particularly in Europe. And finally, the working go live for this is going to be in mid to late May. We're currently in testing mode and finishing off the documentation, but it is pretty darn close. So that's it. We're done. I'm not dancing. So the entire team is really thrilled to be, so close to a final release of the product. It's been a joy to work on, and we're here. So thank you. And what questions do you have?
If you do have questions, just raise your hand if you're up on the mezzanine. Sorry, you have to come down. I'm not coming to you. We are recording these sessions and we post them online later, so please come to the mic so we can hear your question, and take it away, Tom.
So I noticed you mentioned that the SOCL aggregate limits were one of your key motivations for taking this on. So how angry did the summer release notes make you, having made that decision? The point being that SOCL aggregate limits are now one row per aggregate result rather than per row contributing to that result?
Yeah. Yes, that was a little like, okay, too late now. But at the same time, aggregate SOCL, the number of rows, though being an important factor, was not the only factor. We were still been limited by many other things within that. But I'm actually trying to turn that around and look at the excitement of it, going, wow, hey, I can now find out the exact number of related opportunities in a single query. I don't have, other than maybe CPU timeout, right? If you're trying to do a count against 30 million, it might actually bomb. But I can still do that at a single row without blowing up governor limits. So yeah, both frustrating and, ooh, look at this at the same time. Thank you. Right up here.
Hi. One of the previous problems with rollups is you can't do cross-object, or let's say it has to be the parent-child type of rollup.
Is that standard roll-up summary fields?
Standard rollups.
Oh.
Fields. Okay. Will this take care of that? I mean, if you...
This is very specific to the Nonprofit Success Pack.
Right.
So it's
what
not a
we're working in.
standalone.
Right.
So it will not, if you wanted to do something that's not part of donations, then you would use another tool like DLRS or Rollup Helper. But if you're trying to roll up, let's say, I don't know, payments might be an example of another object like that. Customizable rollups will roll up payments to an account or a contact, right? So in that case, it's a child of opportunity. So that's along those lines, but again, it's very specific, right? It's not going to work with any custom object.
Right. Okay. You going to be around today?
I will be here all day.
Okay. Thank you.
So can you explain what is going to deploy in terms of, I assume all the current rollups, of course, are going to just move over, but are new rollups that are now possible going to be created for us, or are we going to be building 50 new rollups that everybody in the nonprofit world wants?
That's a really good question. So the first thing is that we're not turning this on. This is a new set of functionality. The old rollups still exist. They are still there, and they will continue to run. So when we deploy this out with our package update, we for those that don't know, we push updates to the Nonprofit Success Pack every 2 weeks. Every 2 weeks to every organization. That's 40,000 customers get an update to the package every 2 weeks. So when we push this out, it's not going to turn on automatically. Your rollups won't change. They'll still be what they were. When you enable it, it will create the configuration based on whatever your settings are, because your settings for rollups might be different than somebody else's settings. But it's only turning those on for the rollups that we've already got packaged. Those 41, for example, that I listed on the contact. We're not deploying new types of rollups with this. So let's say now we can roll up payments. So we could have a rollup on the account object that says, or the contact, total payments or total written off. We could have that and we could push that out, but we're not. We're keeping everything the same. So for all intents and purposes, if you enable customizable rollups, you should see no change. It should look exactly as it did the day before you enable customizable rollups. But then you could go and create your 50 new rollup types if you so desired, which would be a lot, but you absolutely could do it.
I don't know if this is a question for you or perhaps Michael. I don't know if it's a question for you or Michael. A couple weeks ago, they helped me create some stuff with Dolores. And will what you're talking about overwrite what we've created? Or will they continue, there won't be any problem?
Well, Dolores is a separate product and is a wonderful product for that matter, and can roll up many other things that what we're building does not do. As I said, we're very specific to the NPSP data model. So unless you've written a roll-up that writes to a Nonprofit Success Pack field, right? Mike is shaking his head. Then it doesn't overwrite anything, right? You would have had to have somehow overridden what NPSP was already doing for that to have been the case, and you would already be seeing it being overwritten every night.
Mike, it looked like from your presentation that the new rollup engine is generalized well beyond currency rollup types. You mentioned aggregating campaign information at one point. Could you talk a little more about how broadly we can aggregate different types of data, like allocations given to by a specific donor, for example?
Sure, that's a good example. Think about that one. Allocations given to by a specific donor. So in other words, you might want to have a roll-up field on your general accounting unit that says, these are all the allocations by Joe Smith. Is that what you're thinking of?
I'm thinking of a specific ask that I had from a nonprofit once. We wanted to see on their contact records all of the allocation units to which that donor had given. Is that, and more generally, just is that kind of data something that's supported by this roll-up engine beyond date and currency values?
Yeah, good question. Well, so I'll do it in reverse order. There's a number of things that are supported beyond date and currency. For example, I could say, let's say I put a lookup on the contact for last campaign donated to, and it's a lookup to the campaign object. I can have a roll-up that says, get the campaign from the last donation that this contact made and put it in this lookup field. And so I will always have on my contact a lookup to the last donation the last campaign that donor donated to. So we can aggregate many different types of things now. More specifically though, right, your question being general accounting unit is a table. So there could be 2 general accounting units, right, or allocations, or there could be 1,000. So it would be difficult to roll up for 1,000 different possibilities dynamically. But if there were, let's say, three general GAUs that you always wanted to know about, you could literally create a roll-up field on your account and have that set up to say, roll up all allocations. I think this would work. Simply off the top of my head and safe harbor, right? Where the allocation is XYZ. I'd have to put some thought into that a little bit later after maybe some more coffee. Maybe it would work, maybe it wouldn't work. Can't promise that. All right. Thank you, everybody.